Let's talk about the heavy hitters of the periodic table. Transition metals are the ultimate all-rounders. Physically, they are super strong and dense with high melting points, so they stay solid even in high heat. They are great at moving heat and electricity, and you can hammer or pull them into shapes without them ever snapping. Chemically, they are just as cool. They can change their charges when they bond, creating chemicals with bright, vivid colors like blue, green, and purple. Plus, they act as catalysts to make other chemical reactions happen way faster.
Now, let's look at how this metal work in the real world. Their most powerful role is as catalyst in large-scale manufacturing. First, iron is the key catalyst in the Haber process. It combines with nitrogen and hydrogen to produce ammonia. This is vital for the global agriculture industry because ammonia is used to create the fertilizers that grow our food. Second is vanadium 5 oxides is used in the contact process. This produces sulfuric acid, which is essential for making everything from detergents to car batteries. Finally, transition metals like platinum and palladium are found in the catalytic converter. They convert toxic gases from car engines into safer emissions, helping to reduce air pollution. From feeding the planet to protecting the environment, transition metals are the engines of the modern industry.
If you really want to learn or to understand why transition metals work as a catalyst, this video might be for you. As we already know that the transition metals are effective catalysts because they lower the activation energy of reaction by providing an alternative reaction pathway. Here's the science behind it. Let's break it down. First of all, transition metals have variable oxidation states, which means transition metals can lose or gain the electron easily, and because of that, they manage to stabilize the high energy transition states by reducing the energy needed to start the reaction. In addition to that, variable oxidation states allow them to form temporary bonds with reactant molecules. It also allows the transition metals to transfer the electron during the reaction. Apart from that, transition metals have the formation of intermediate complexes. Intermediate complexes, What is that? An intermediate complex is a temporary compound formed during the chemical reaction between catalysts and reactants. In other words, transition metals are oftenly form the temporary intermediate compounds. These intermediates are actually more stable than the original reactants. This is because the formation of intermediate complexes is also known as the step-by-step pathway. This step-by-step pathway has lower activation of energy at each stage. I repeat, at each stage compared to the high energy step. To conclude, the transition metals act as a catalyst by providing an alternative reaction pathway with a lower activation energy. The variable oxidation states allow them to form temporary bonds and intermediate complexes with reactants. Well, I guess that's all I have to say. Thank you for your time, thank you for lending me your ears, and have a good day.